Good evening, everyone. Thank you very much for joining us today for this webinar. Let me introduce myself, and my name is Godwin James. I am a second year PhD student at National University of Ireland, Galway. I welcome everyone for the fourth webinar on International Career Talk webinar series. Today, we are switching gears a bit from biotechnology and bioinformatics to environmental engineering. In case if you missed the first three talks, you can watch it on YouTube channel of ours, LLB School. Today, I'm very happy to welcome our guest speaker, Dr. Jagadeeshkumar, joining us all the way from Queensland, Australia. Thank you, Dr. Jagadish, for accepting our invitation. Dr. Jagadish will be sharing his career journey in environmental engineering and what career opportunities available overseas. So stay tuned for the talk. Before I want to introduce our new initiative, can you move to the next slide, sir? Yeah, so I want to introduce our new initiative, Futura from LLB School. So we we this initiative was to connect graduate students, researchers, and professionals in biology and bioinformatics under one roof to share knowledge and collaborate. So basically, we offer a range of services. Basically, we collaborate with researchers. We help you collaborate with researchers, and also you can work as a freelancer with us. And we have also tutors in different areas. And stay tuned for this. And we have expert consultants with the LLB school, so you can also join with us and help improve your research. So you can also go to our site, llbschool.org. So next slide, please.
To give a talk. So I just thank Godwin James and Ms. Vinita for the introduction. Though there is some technical issue, I'm sorry for that. So today I'm going to talk about can I do research overseas? So it's a career journey in environmental engineering and its opportunities. Can I do research overseas? This is the question which made me come to Australia. This talk, I just made this talk into two different sections. The first section, I'm just going to talk about myself and my journey to Australia. So I'll just try to touch a little bit basic on wastewater treatment. And because we have a wide range of audience here, ranging from different disciplines, so I'll just give a little bit basic on wastewater treatment. That's my specialization as well. So I'll just talk a little bit about my PhD research because I spent 4 years of my life in my doing my research. So it will be injustice to myself if I'm not talking about it. So please bear with me for some time till I finish my PhD research. And then the interesting talk to you guys, like I'll just talk in section two, like it's like a career opportunities in environmental engineering, both in India and in overseas. I'll just like try to talk about the process that we have to go through to get a PhD scholarship in overseas. And I'll just talk a little bit about the excellent master's opportunity that I just recently heard in University of Newcastle. I just uh, talk a little bit about it and the eligibility criteria that you have to uh, get into that master's opportunity. So, so it's a for myself that I just put an education background. I'm sorry for the technical issues that we have gone through. So I'll just talk a little bit about my own educational background. So I did my bachelor's in energy and environmental engineering in Tamil Nadu Agricultural University from India. So energy and environmental engineering. It's when I started it, it's a kind of like a non-popular course. Like most people didn't know about this course. So me and my parents like came to know about this course from our neighbor, like saying that there is an energy and environmental course in agriculture university. We didn't know what this course is. So me and my father went to a university and came to know about the courses that they are offering. So I just enrolled just to finish the degree and then get my job after my degree and then get married and settled in India. So during that time, I did my research on conversion of waste tires through pyrolysis and producing secondary value-added products. So yeah, I just don't want to go into much details on the project that I worked on during my bachelor's because it's a bit critical to cover everything. So I was supervised by Dr. Subramaniam. He's a present professor and head in the bioenergy department in the Agriculture University. So he's a very good motivator. He always motivates us to take a big step to just go ahead of what we are thinking. So just take this opportunity to thank him for motivating us. So yeah, as I said, it's kind of like a quite unpopular course at the time when I started it. So now this course is gaining like more importance and like getting popular. So I just talk about like what are the courses that we dealt with during our bachelor's. So because like most people are not aware of what is energy and environmental engineering. So I'll just talk about a little bit on like the courses that we have been dealt with. So we were taught like more on the renewable energy side. So which contributes for the environment benefits. So we just talked about like solar energy, wind energy, bioenergy, and geothermal energies. So I'm not going to talk anything about like what these energies are. So it's better you guys can search it in Google. It's lots of things are available. So and also like we were dealt with the energy auditing. So energy auditing is nothing but like it just like calculates what is the energy consumption that we are doing in our houses and the industries, just do some auditing there, and then like just consult them with any advanced technologies to reduce the energy consumption and electricity and like that. So and on the environmental side, we were dealt with the solid and liquid waste that we generate in our households and industries, and what is the best treatment methods and the management techniques that's available. And also we were dealt with environmental impact assessment. So environmental impact assessment is nothing but if an industry is getting like built in a particular area, they have to go through this environmental impact assessment process. So where they have to assess all the environmental impacts that the industry is going to cause in this area, and then like they have to get the clearance. So we were dealt with like how what are the process to has to be followed to get the environmental impact assessment, do the environmental impacts and assessments afterwards. So it's really like it's a very interesting course, like it's a more on the application oriented course. So I was a bit fortunate. I was thinking that now, and I felt like I'm just a bit fortunate to enroll in this course. So after finishing my bachelor's, then I just thought like what to do for my master's. So whether I need to go for a job or just do masters. So one of our course coordinator, he was suggesting like it's better to go for masters because I was still naive at the time, so I didn't know like what I had to do in my life. So I just did my masters there. I just did my agriculture engineering there. Just it's a specialization in bioenergy. Bioenergy is nothing but just producing energy from the biomass. So through gasification, pyrolysis, and biogas technologies. So yeah, so I did my research on anaerobic wastewater treatment there using a packed bed media. It's a high rate reactor. So as I said, I'm not going detail there. I'll just talk about wastewater treatments and other stuff in the future slides. So I was supervised by Dr. S. Kamaraj. He was a retired professor and head the Department of Bioenergy. So this is the reactor on the side of the slides, like which I worked during my masters. So during my masters, I found out that I have a very big passion for research. So it's really it's a life turning point there. So I was doing one of the exhibition in just presenting my research there. So at the time, like I felt so happy like doing research. So I thought like, this is my future, so I just need to pursue my career as a researcher. So after finishing masters, I was the consulting from my professors, and they were saying like, just go ahead, just go out of the university, get some exposure and other stuff. So I was trying to apply like for Indian Institute of Technologies, IISCs, but I failed everywhere because like, I failed. So I was thinking of like waiting for another 1 year to get into IITs to do my PhD there. So at the time, I was thinking like, while I'm waiting for 1 year, so why can't I go for try and overseas? So that's the point, like where I just thought, okay, let's explore the opportunity of doing PhD in overseas. So from there, I just came to do PhD in Advanced Water Management Center. It's located in the University of Queensland. It's a top university, like number 3 university in Australia. So I was a bit fortunate to get supervised by Dr. Guangming. So he's my principal supervisor. His expertise is in sewer corrosion and other stuff. So I'll just explain what are those in the future slides. I'm just supervised by Professor Yerk. He's the deputy director of the center, and Katrin. So she's expert in drinking water systems. And Professor Jigwo, he's the director of our center. Excuse me. So I was working on the project like it's an integrated urban water management using iron salt dosing. So yeah, this project was funded by different industries from Australia, from Singapore, from US, and the Australian government as well. It's a linkage project. Yeah, so I was a bit fortunate to get into AWMC, so I'll just talk a little bit about Advanced Water Management Center. So it was established in 1996 in the University of Queensland. So it has a wide range of research expertise there, and so lots of fields, their research fields are undergoing, they are undergoing lots of research fields there. So they do sewer corrosion and water. They do a lot of advancements in drinking water treatments. They do lots of research in nutrient and resource recovery. So, and there's like a huge gap and huge opportunities available for environmental biotechnologists and microbiologists there. There are lots of interesting projects they are undergoing in AWMC. So I'll just talk about like what are the current amazing research that's going on in AWMC. So an AWMC is it's particularly well known for sewer research. It's number two center in the world to do sewer research. So I'll just talk. So when I'm just talking about sewer research, what is sewers? What are sewage systems? It's like in India, like there's in India, like particularly in South India, it's like the wastewater treatment systems we have decentralized systems, which means like we don't have a centralized, not in many places, so some places has, so not in many places we have a centralized wastewater treatment systems. So by that means decentralized system is nothing but every household has its own septic tanks and other stuff, which might be like cleaned yearly once, or like maybe 10 years once, something like that. So but in Australia we have a centralized wastewater treatments, like every household and the industries produces wastewater. It goes to the sewage pipes, sewers, the pipes. So from through the pipes, it goes to the wastewater treatment plant. So when the wastewater is going through the pipes, so not all the surfaces are common. So there are some uphills there and there are some downhills there. So there are two different section of gravity, like sewer pipes there. So one is a gravity pipe. So gravity pipe is nothing but the wastewater flows in the pipes on under the influence of gravity. So you don't need any pumps or something like that. So but once the wastewater is in the downhill, so if you want to pump the wastewater to the uphill, so you will use a pumping station there. So you will pump the wastewater from that manhole to a uphill, and then like from there it goes again to the gravity pipe before it reaches the wastewater treatment system. So this is a general concept about like sewers. So as I said, like there are two types of sewers, like one is gravity sewers and one is rising main. Rising main is nothing but the pressurized systems where you push the water, where you pressurize the water. So when you're pushing the water inside the inside the pressure mains, inside the rising mains, so the water inside the pipes will be like completely filled. So when it is completely filled, it will be like it will not have any air inside, so it will maintain an anaerobic condition inside. So like we clearly know that like wastewater is it's a breeding ground for, also like it has lots of microorganisms inside and suspended solids there. So when it is going through the rising main sewers, it forms the biofilms around the pipes. So which I mentioned here, it's an anaerobic biofilms there. So these biofilms, it's a breeding ground for like anaerobic microorganisms because the pipe is an anaerobic condition. So it provides a breeding ground for anaerobic microorganisms, particularly like methanogens. So it produces methane by utilizing the carbon sources present in the wastewater, and also it's a breeding ground for like sulfate reducing bacteria. It's a kind of anaerobic bacteria. So yeah, you guys are much aware of the biofilms and bacteria. So these sulfate reducing bacteria reduces the sulfate. The sulfate is it's a huge amount of sulfate will be present in wastewater because of the soaps that we use and from the drinking waters that we use. So these sulfates will get reduced in the anaerobic condition and produce sulfide in the rising main sewers. So as I said, once the wastewater is getting pumped from the rising main sewers to the gravity pipes, so gravity pipes is inside the gravity pipes, the wastewater will flow under the influence of gravity, as I said. So once when the water is getting fast under the influence of gravity, so the water will have both aerobic phase and the anaerobic phase because it is not a completely filled section. You can see in this diagram here the gravity sewers. So once the water is flowing in this one, it has both aerobic phase and anaerobic phase. So the sulfide that has been produced inside the rising main sewers will get released from the liquid phase to the gas phase. Sulfide releases into the gas phase because it is an aerobic system, so it has oxygen there and it has moisture there because it's a wastewater. So and it produces sulfuric acid on the top surface of these pipes, so which causes like corrosion, because it's sulfuric acid. It reduces the pH and causes corrosion. So once the corrosion getting developed, and like sulfide is also like it's a waterous compound and it's a flammable compound. So it's accumulated in the sewer pipes and it may affect like uh, in the cracking of the sewer pipes, and sometimes it may get exploded. So there are lots of cases that happened like where the sewers getting like exploded. So at that time, it's a huge headache for the urban water utilities. It's really hard to repair those systems because they have to block the roads, they have to change everything. So it's a huge cost management system as well. Sorry. So the water utilities, like they have to control sulfide in order to reduce the management cost and in order to reduce the repairing costs and maintenance costs. So there are lots of steps they follow to control sulfide inside the sewer environment. They inject air inside the waters or pure oxygen so that like the sulfide gets reacted with oxygen and it forms sulfate back. So which is not like dangerous as sulfide. And there's another method where they will elevate the pH of the wastewater by using MH and magnesium hydroxides. Like the sulfide will not get released from the liquid phase to the gas phase. It's because of the pH difference. And also, like there's another method where they used to precipitate the sulfide by adding like a metal salts. These metal salts, like they use iron or like zinc or something like that. So iron salt is its dosing is a common technique that we follow in Australia. It's either ferric or ferrous because it has a lot of benefits over other technologies. It's a bit cost effective as well, and it's highly specific to sulfide. So if you just put iron in the anaerobic condition, it reacts only with sulfide. It will not react with any other compound. I'm talking about anaerobic conditions. In aerobic condition, it's different. I'll talk about it later. So the iron gets reacted with sulfide and it forms ferrous sulfide precipitates or particles, so that like the sulfide will not get released into the gas phase. So just keep the sewer part aside. So I'll just talk a little bit on the wastewater treatment now. Then I'll just combine the wastewater treatment and the sewer systems. So once the wastewater is coming from the sewage systems, it goes to the wastewater treatment process. So most common wastewater treatment process, the conventional wastewater treatment is it's an activated sludge process. So the wastewater comes from the sewer network and goes through the primary treatments, which is nothing but the screens to remove the sands and other particles, and then it goes to a primary settling tank where the solids get settled and the liquid phase goes to the bioreactor. So in the bioreactor, there's three different zones, which is an anaerobic zone, an anoxic zone, and aerobic zone. So they use these bioreactors to remove the nutrients from the wastewater, particularly nitrogen and phosphorus. It has to be removed from the liquid before it is getting discharged into the effluents, because like these nutrients gives rise to eutrophication like algal bloom, and it causes lots of problems. That's why it has to be removed. So there are lots of regulations for each government and for each states. Like there are certain limitations and certain regulations that the wastewater treatment plant has to follow before they discharge the water into the aquatic environments. So they use bioreactors there, where it's a microbial process. So 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 the water coming from the primary settling tank like mixes with the activated sludge, which is coming from the secondary clarifier again. The activated sludge contains the microorganisms like residing inside. So it reacts, it undergoes different processes and removes the nutrients from the wastewater. So particularly nitrogen as NPS and phosphorus will get utilized by the microorganisms for their growth. And then like it goes and the water goes to the secondary clarifier where the sludge gets settled and the sludge returns back to for the treatment, and the water goes to the disinfection stage and it gets disinfected to remove the microorganisms in the wastewater, and then it gets discharged to the water. So once the sludge is getting like older, like some of the old sludges will be taken out from the bioreactor and it goes to the anaerobic digester for recovering the energy. Like for the carbon sources will be recovered in the form of biogas. Biogas is nothing but the methane and the hydrogen sulfide and carbon dioxide and carbon monoxides. So on the bioenergy, like the methane will get utilized for producing electricity, producing heat. So some of the treatment plants, like they don't have effective phosphorus removal. So they dose chemicals there in the bioreactors to precipitate the phosphorus. Like they use iron salts or alum salts. So the iron and alum reacts with the phosphorus present in those wastewater and gets removed as a precipitates. And then like they dose chemical again in the anaerobic digester. So they just dose ferric or MHL there, magnesium hydroxide there, to reduce the sulfide emission, because anaerobic digester is again it's an anaerobic condition where the sulfate gets reduced to sulfide and gets emitted, and it causes lots of problems for the utilization of biogas. So so they dose iron or MHL to reduce the sulfide inside the anaerobic digesters. So they just uh, they dose chemicals at different stages. Like they dose chemicals in the sewer network to remove sulfide as iron sulfide particles, and they dose iron again in the bioreactor in the wastewater treatment plants to precipitate the phosphorus, and again in the anaerobic digester to remove sulfide as iron sulfides. So my research, like now, it's not only my research; it's a team effort. So our research, like we just focused on reducing reducing the iron salt dosing or reducing the chemical dosings. So we just like eliminated the use of iron salts, like both in the bioreactor and in the anaerobic digester, with the assumption that the iron dose in the sewer networks, so it forms iron sulfides inside the sewer networks, right? So it's the same wastewater goes to the bioreactor. So iron has a specific, like specific capacity. Like once the condition changes, it also changes. Like it has certain redox potential. So the iron sulfides along with the wastewater goes to the bioreactor, where in the aerobic phase the iron gets cleaved from the iron sulfides, and the sulfide will get like oxidized to sulfate, and the iron will be available for precipitating with phosphorus, and it forms iron phosphates there, and it gets settled in the sludge. And once we take the sludge that contains iron phosphates and put in the anaerobic digester, again like the condition changes, and like it produces sulfide. So the iron cleaves from phosphates and then attaches with sulfide and forms iron sulfides. um, just this method in pilot scales and full scales, and we just published a couple of papers. And so we did like we did found like a simple change can like have a potential of saving up to like 1.5 million Australian dollars per year when we are applying this to all the treatment plants in Australia. So that is one aspect of my research. The other aspect of my research talks about like a removal of micro pollutants from the wastewater when we dose iron in the sewers. So I talked about how the corrosion is forming inside the sewer environment and what are the effects there. There is another big problem in the wastewater is like the micropollutants. So micropollutants, how it ends up in the wastewater is like we drink coffee, we drink tea, we use soaps, we use lots of micropollutants, we use medicines. So all these things it gets it has some biosorption and utilization inside our body, like maybe like 60 to 70%, and the remaining compounds will get released when we urinate or and some people like they just dump the unused medicines in the toilets. And there are some farmers, if there is any pharmaceutical industries and you are getting the wastewater from them, so obviously those will have like lots of micropollutants in it. So these treatment plants are not like well designed for these micropollutants. It is called micropollutants because it's available in very little amount in wastewater, like maybe like micrograms per liter. So if you are not properly removing those in the wastewater treatment plants, and it may end up in our drinking waters. So that's why we were just I'm concentrating on other aspects, like when we dose iron inside the sewer environments, like it forms iron sulfides, FES. So whether that FES is having any beneficial effect on removing those micropollutants from the wastewater as well. So that leaves like all the PhD research that I am doing for the last 4 years. So there are some other interesting research topics that is currently ongoing in Australia and in my center. So one is like drug consumption analysis using sewage. So as I said, there will be like lots of micropollutants that is available in the sewage, right? So there are some laboratories, they take sewage and analyze how much drugs is present, and like analyze back calculate like how many people are consuming those drugs in a particular area. So it's called sewage epidemiology. So it's a current interesting topic that is and also I find it interesting because I haven't heard of such topics before. So and also like there is another research that's going on, like it's an elimination of PFAS from wastewater. PFAS is nothing but it's also a kind of micropollutant. It's like a fluorinated compound. It's usually found in wastewater, also like how it ends up is like we use soaps and we use non-stick pans and other stuff, right? So for cooking, so those non-stick pans, the coatings that they use, it contains PFAS as well. So and in Australia, it's Australia is prone to lots of bushfires. So we use lots of firefighting liquid to tackle those bushfires. So those firefighting liquids has like PFAS, are used there. So it's a huge topic, for eliminating those PFAS, because it has a lot of harmful effects on human beings, if we consume it. So there's a huge funding that goes into this elimination of PFAS from the wastewater. And and the recent topic is the coronavirus that's going around everywhere. So that is like a huge topic that's going on, as just taking the sewage and analyze the RNA of COVID-19, like the SARS coronavirus 2, the RNAs in the sewage, and then like just back calculate like how many people get infected because of this virus. And what is this fate in the wastewater treatment plant? What is this RNA fate in wastewater treatment plant? Will they end up in our water and will get get in our drinking? How it affects us? And like, is there any better disinfection strategies that is available to remove those viruses from the wastewater? As current research is going on there. So yeah, now let's just talk the career perspective and PhD in overseas. So, why not India? So, is there not any career opportunities in India? Yeah, of course, there are lots of career opportunities for environmental engineers in India. So, you can either go for like research-related jobs in IITs and IIS, Indian Institute of Sciences, VITs, and etc. So you can find easily academic jobs in universities, because lots of civil engineering courses deal with wastewater treatments and other stuff. So they of course need some environmental engineers to teach those courses. So yeah, it's lots of academic jobs are available and research jobs are available in universities, and lots of consultings in private sectors, like both energy and environment. So lots of my friends are like being employed in like doing energy consulting, like particularly on solar industries, consulting like lots of big solar power plants and solar power projects. And there are lots of environmental concerns are there, and some government sectors like MNRE, like Ministry of New and Renewable Energies in Delhi, and like pollution control boards and etc. And there are lots of like non-governmental organizations like concentrating more on tackling the environmental problems. Yeah, of course, there are lots of opportunities available there. And like there are lots of entrepreneurship opportunities in renewable energy sector. Lots of my juniors, like they started like solar energy companies and others. Yeah, they are just doing very well. And like consulting, yeah, you can be a private consultant as well. Like just approach the industry and just try to tackle their problems and then just earn a lot of money. Why do PhD in abroad? So this is the question for yourself. You have to answer yourself like, why I need to do PhD in overseas. What's my long-term career goal? So whether I need to do PhD in overseas and settle over there, or just want to come back and do some major groundbreaking research in back India or like in your home country. So, and yeah, these are the questions you generally have to answer. Like, what do you want to do after your overseas PhD? Whether you want to get a job in the overseas there. So once you have answer for these questions, like, you can just easily figure out which country you want to go and other stuff. So this is the one like the source I found like where they mention like why you want to do PhD in overseas, what are the benefits. So yeah, of course you will get more opportunity in your field, particularly like once you narrow down like on which field, on which path you are going during your masters, then you will find like which country is like good for your particular field. Then you will get more opportunity in that country if you are just going for it, and you will get better funding and scholarship. Yeah, of course, like so you can get easily a scholarship and you don't need to pay, because most of the countries they will just waive your tuition fee. You don't need to pay tuition fee. And yes, and you will get some living allowance scholarships which will be enough for you to survive overseas. And yeah, widen your network. Yeah, you will get lots of connections, particularly environmental engineering. It's a environmental engineering. It's an interdisciplinary course, so you can't able to rely on one subject. So you need to know a little bit of civil engineering, you need to know a little bit of biotechnology, because biotechnology, microbiology. So you need to know a little bit of mechanical, chemical. Yeah, it's an interdisciplinary. So you can't able to learn everything by yourself. So you have to widen your network. You should have lots of collaborations in order to get good funding and in order to get lots of research outputs. Yeah, and of course, the another thing is a cultural exposure. So you just go outside, get some cultural exposure, and see how they are approaching a problem and how they are living their life and balancing work life and everything. It's just to get cultural exposure and then go back India, and or if you want to go back, yeah, so go back and do some groundbreaking research there, or just settle. Yeah, it's up to you. That's the question you have to answer yourself. So, and also like procedure to obtain scholarship. So, this is the basic question that I usually get from lots of my juniors. Like, they will just approach and they'll just say, "Sir, just let me know what are the opportunities available." So, yeah, I'll just like go through like what is a basic procedure you need to go through to obtain a scholarship. So, during your masters, so just try to get some papers published. So it doesn't matter what is the quality of your publication, so it matters like sometimes it matters like the quantity. So you can just concentrate on the quality of your research when you are doing overseas PhD or doing research, just going ahead. But for masters, like just try to publish, even if it is like a low impact journal, it's fine. Just get like number of publications, just get your publications up, and then like prepare your resume. Just prepare a resume like with international standards. Just don't follow a usual standard that you will apply for jobs like after your bachelor's and other stuff. Just try to see, there are lots of like formats available in the website. So you just go through and get the international format and then just prepare an international standard resume. And then the important thing is browse yourself for universities and supervisors. You just approach a person and asking like, no, what are the opportunities? He can guide you, but he can't able to get everything, what's your research interest is, what you want to do, what's your next aim and other stuff. Browse for universities. Just there are lots of opportunities available when during this era. Lots of technologies available. Just go through. Just check for individual universities. Check for individual supervisors' profile. Everything is available in the website. Just find out like what's their research field and whether it matches your research field. And if it matches, then prepare a short research proposal on their research interest, no matter whether they have funding or not. Just approach them with a short research proposal that you want to do this kind of stuff. Whether it is good or not doesn't matter. Just prepare a research proposal and then approach them just by sending an email by yourself. Just approach them personally. So just don't think that they won't respond. Most people will respond. Most of the foreign professors, they will just respond to your email, whether they have opportunity or not. They will respond, but you have to wait. So that's in order to get a PhD, a scholarship in overseas, you have to have three critical P's in yourself. Like one is passion. So you have to have passion to do research, of course, and then you should have perseverance. So you can't able to you send an email today and you can't able to expect a reply back in one day or one hour or something like that. You have to have perseverance. So when I was approaching a PhD opportunities, just approached more than like 70 professors. So and I got one response from like 10. It's you have to have perseverance. So and then you of course you should have a PC and internet. That's enough. You have a computer, you have internet. That's enough. All the information is available on the website. You just have a passion. You just have a passion and just search for yourself, find it, and then if you have any doubt, you approach them. You just say how the country is, how the universities approach the seniors, and I find. But you can't able to expect your seniors will do everything for you, because it's your research interest and everything. Career opportunities after PhD. So it's a general myth in India, because yeah, it's a general myth. I heard a lot for myself. So they say our PhD is overqualified. So it's completely wrong. It's not like that. So PhD is now it is now this present era is like PhD is a must. You just need to do PhD and lots of industries are preferring PhDs to do work on their research and development. So and there are lots of postdoc opportunities in the upcoming research topics. So PhD is nothing but your ability to learn. It's not like you are one specific field and you just go for a postdoc in one specific field. It's not like that. So you can just expand your research topics and you can just expand your knowledge when you're doing postdocs. So yeah, it's career in research and development section major water utility, other environmental fields. Yeah, environmental consultants and scientists in the private sectors, and you can be an entrepreneur by yourself, because by the end of your PhD you will know what are the technologies that you have gone through and what are the technologies available currently, and you can be an entrepreneur by yourself for sure. So yeah, so now I'll just talk about the master's program that I recently heard from one of my professor. So it's an excellent master's program that is available in University of Newcastle. So the degree is they just provide masters in material sciences and engineering. So it is really hard to get a scholarship for masters. So you can easily get scholarship for PhD because all the professors will have funding, but it's really hard to get scholarship for masters overseas. So so this program they just collaborate with PSG Tech in Coimbatore in South India. So they just have 1+1 program, so which is just do 1 year masters in PSG, and then you just come over here and do a remaining 1 year in Newcastle, University of Newcastle. So and they just later plan to expand this program to the VIT and SRM in South India. So and they are providing 50% scholarship for the students who is having more than 80% of their merits, 80% of their, so which comes around 15,000 Australian dollars per year. And and I hear from the professors who is providing the masters there, they are saying if they are doing masters there, they have an opportunity to be a research assistant in the same lab. So which fits you guys as around again $15,000 per year. So the total tuition fee is around 38,000, but you will get like 30,000 in return. So the remaining $8,000 you have to spend it by yourself, and that is a very big opportunity. If you're doing like a masters in overseas, you can continue doing PhD in the same lab, or like I just maintain a good relationship with your professors. They will just help you get some like some industry related jobs and other stuff. So, and what is the eligibility for this course? So, you just have to have a 4-year bachelor degree in any engineering, except computer and information technology. It doesn't matter like which engineering you are, eligible, except like computer and information technology. And if you have completed 3 years of bachelor's in science in the top 20 engineering colleges. So these 200 engineering colleges. These colleges has been like listed in the National Institute ranking framework. So you can just go through if you are doing bachelor's of science in 3 years. If you complete a third year in bachelor of science in these engineering colleges, you have an opportunity to come directly over here and pursue your master's program. So, and also like for the master students who complete their first year with more than 60% marks, and they can come over here and do the remaining 1 year in the University of Newcastle. And like you have to go through like the English qualification test for the visa, so it has to be like overall like more than 6.5. It's really a great opportunity. It's such really like very rare to get scholarship. So hope you guys will utilize this. So yeah, so can I do research overseas? Yes, of course. Why not? So thank you. That's the end of my presentation. So if you have any questions, happy to answer
Uh,
it.
Thank you, sir. Thank you very much for the talk. It's very nice to hear from you about so many opportunities, and we have many questions coming up. So
Yeah.
probably we'll start with this question. Could you tell us the scope of biotechnologists and bioinformaticians in wastewater treatment or in general environmental science research? This question is from Mahesh from LLB School.
Yeah, when I just talked about like the wastewater treatment plants, like I said like they just go for bioreactors. So bioreactors like they have lots of microorganisms there, and like yeah, of course like lots of biotechnologies are like doing some amazing works like just trying to which are not very good in biotechnology, but they are doing some lots of works like try to engineer the microorganisms and get less energy outputs, and like now there are some microbiologists working on the biofilms like to analyze like which microorganisms contribute for which process and other stuff. So yeah, so there are opportunities in wastewater treatment alone. So if you go for like another environmental engineering, yeah, of course, like they have lots of opportunities for biotechnologists and microbiologists.
Oh, yeah, that sounds good. So I have a question. So was the sewage water after treatment, do they use in Australia, for instance, for agricultural purposes, for irrigation or something like that? Do they?
No, they don't. They don't actually. So they just put it in the ocean or like woods, and then they will just take it back and then do treatments and then use it. It's called indirect reuse. So
Okay.
after doing that, after finishing the treatment, they do disinfection and then do that. And some of the treatment plants they go for advanced treatments and then like they utilize it for like for gardening, as you said, for gardening and other stuff. Yeah, there are some treatment plants, but
Yeah.
they just go through some advanced treatment, membrane treatment and RO treatments, and they will
Yeah.
have some certain limitations. So they will just like show that they accept those like they have those limitations satisfied before they use it.
I see. Yeah. I see in some countries like Israel, they use a lot of treated water for agriculture and irrigation purposes.
Yes.
So I was just
Yeah. Yeah.
wondering about that. And so the next question is, I think it's a bit generic question. Can you tell us few colleges in and outside of India for bachelor and masters in environmental science?
Yeah. So, so like no, say it. So
I
You know,
have.
most of the, yeah, I'll just answer a little bit. So most of the people who is doing masters in environmental engineering, they come from civil engineering background or chemical engineering background. So as I said, like environmental engineering, it's a kind of an interdisciplinary area. So it's very rare to find environmental courses like, so agriculture engineer, Tamil Nadu Agriculture University, they provide energy and environment course. I'm not quite sure like which university other than TNAU is providing those. I think there's one course in Anna University as well, and
Yeah.
Bharatiya University has one. Yeah.
I would recommend the participant to look at the three P's needed for obtaining the scholarship again. So the answer for that. So the next question is from Nichita. Can we do PhD in environmental sciences after our MTech or MSc in life sciences?
Um, that's an interesting question, but I don't have an answer with me now. So probably yeah, just go through the eligibility criteria. So they will just surely uh like denote the eligibility criteria for each course they are offering. Yeah. So there are some life science people like who is doing PhD, but I'm not sure whether they can like directly go through or something like that. But if you just approach the professors and if they like your profile, no matter what, like they will just try to get you in.
Yeah. So there is a question from Nisha. So it's a very informative talk. So I have few questions. How India is managing its waste? Is it also have sewage plants? What are the harmful effects of consuming treated water?
Yeah, so in India, like India has some treatment plants, but not like a lot of treatment plants back in India. So particularly in South India, if we talk, there's one big treatment plant in Coimbatore. There's one big treatment plant in Chennai, so where they do treating the wastewater and then they will just discharge it. But I'm not sure like how good quality the water they are producing it. So so for that question, yeah, for North they have like lots of water treatment plants in Gujarat, of course. Yeah, they have lots of water treatment plants in India. They do treat the water, but like most people like in India, they have a decent systems, so that they use septic tanks, and yeah, it's a bit like quite inexpensive, like quite cost effective, so they don't need to do much work there. They just dump the waste generating their houses in the septic tanks, and then they clean it like maybe 10 years once or like 5 years once. So it's not creating much trouble. So most people like go for decentralize the systems. And the second question is,
The second
the
question is
question.
what are the harmful effects of consuming treated water?
See, consuming the treated water, it's say that's there are lots of like debates going on, like it's a sentimental thing, like if you guys are given like a treated water and they say like it is a treated water, drink it, would you drink it? Yeah, it's hard to accept the truth, because we don't know that we are just drinking our own waste. So it's there are some debate still going on whether to drink it or not. So most countries, they go for indirect reuse. They treat it and they will just discharge it in the ocean or rivers, and then take the water from the rivers and ocean, and it will go through again the drinking water treatment process, and then it comes. So most countries follows indirect reuse. There are very little countries, very less countries that follows direct reuse. So during if they are doing direct reuse, they have very strict guidelines. Like they have all the microorganisms listed. Like they have to have strict regulations to have to follow the direct reuse.
Oh, great. So the next question is, it's a very general question. How can we treat household waste, especially plastic? I think there are many different
A
types
good
of
question.
plastic and
That's a good question. That's a good question. So I was talking about the master's program in Newcastle, right? So there's a very big research going on there that's trying to get some bioplastics, so which will automatically get degraded because of some microbial process. And that's a very big funding was there from in my own center as well. They're doing some bioplastics research from in the University of Queensland. Yeah. So Plastic waste is really a big thing. So there are lots of researches going on now to control it.
Cool. So the next question is, do we need GRE for research in overseas from Katendra Riang?
It has different eligibility criteria. For Australia, you don't need like you just need IELTS and TOEFL and GRE. Like some countries prefer GRE and some countries prefer TOEFL. Yeah, if you have GRE, yeah, that is also acceptable in Australia. So yeah, you need to go through the universities and see which test they are accepting and for the visa process which is needed, and then you based on that you have to choose like now which test you have to go through. Yeah.
Yep. So the other question is from Sri Lavanya. Is there any postdoctoral opportunities in wastewater management offered at your industry or maybe something like that?
So industries don't directly offer like postdoc position. They will just like collaborate with the universities, and then through the university they will fund any research project, and then like you have to get a supervisor from the university, and then like yeah, for postdoc you also have a supervisor. You will not work on your own. So for postdoc you need to approach, yeah, you need to have a supervisor, and the supervisor should hire you actually.
Okay. So we have 4 more minutes. Probably we'll take two or quick questions. So how did you apply for jobs after your PhD? Question from Vinita.
Yeah, that's interesting question actually. So after my PhD, so I didn't apply for jobs, so I just got it because of my connections. So you have to maintain a very good relationship with the industry partners. So as I said, like my research was funded by lots of industries. So I did lots of industry related works, particularly with the urban utilities. So I just got an opportunity there, and then yeah, I just approached the person who I worked with, and then he was like suggesting like maybe just go apply for it. Then I just applied it. Yeah, it's a personal connection that you are gaining and you are getting when you are doing PSC. That's why, like, when you're doing PSC, network is very, very important. You have to socialize yourself. You have to be open to the opportunities. You should not restrict yourself.
Cool. Yeah. So the next question from Nishita, if there any possibility of use of sewage treated water in aquaculture industry?
There are so there are some treatments out there. There are some grey water systems where they use aquacultures. Yeah, yeah, there are some opportunities, but to my knowledge I can't able to get direct answers for that, so I have to go through the things because I'm not good in I haven't explored those things. But there are some opportunities, and there are lots of interesting researches going on around the world, so you have to just go through it and just yeah.
Yeah. So another different question. So pros and cons of academia and industry in terms of like environmental engineering, probably. Do you have any comments on that?
Yeah, so actually
Hmm.
when I just finished my PhD, I was restricting myself to go only in the academic position because I'm quite exposed to the industry environment there. Then I just when I was doing a PhD, like at the last year of my PhD, then I realized like how important it is to apply the research that you are doing on the fields. So
Hmm.
research is not only in the academia; it has to be like applicable. It has to be applicable oriented, application oriented. So so again, the question, please.
Uh, so they're asking for the pros and cons of academia or industry in terms of environmental engineering. So in a like if you're doing a PhD and
So the
staying in
pros and
academia.
cons. So, yeah, so the pros and cons, like I can't able to list everything. So I'll just like give simple things. So for in academia, you have to be like very active. So you have to like just try to find and try to be ahead of everyone. Just try to see the opportunities, and then and then like right fundings. So it depends on the funding that you are getting as well in academia. So if you can't able to get funding in academia, particularly in the overseas, so probably you won't have a job, so you have to look for some other options. So it's like how much funding and how active you are in the academic positions. So that keeps you going in the academic field. Whereas in the industries, it's not like that. So once you get a permanent position in industries, and then just try to apply the knowledge that you get and just keep learning. So in both industry and academic, particularly in overseas, you have to be active and you have to like keep learning things, because people are like, the research is keep on like emerging and technology is emerging. So you have to be open and you have to learn things quickly.
Cool. Thank you. I think we have some more questions, but we are running out of time, so we'll stop here. And now probably I'll ask Benita Bernard to give a vote of thanks to Dr. Jagadish. Can you unmute yourself? Thank you.
On behalf of LLB School, I thank Dr. Jagdish for accepting our invitation, for being a speaker for this webinar. Thank you very much, sir. Your talk regarding your PhD project was very inspiring, and even more than that, I really loved how you explained how to go about applying for PhD or after PhD opportunities. I think it's very relevant to anyone doing their master's or their or looking to do a PhD. I also thank our webinar collaborators, CBBT, TNAU, and IMOT Forum. And last but not least, I thank all our participants for joining us this evening. Thank you very much.
Yeah, and also I want thank you, Vanita, and Jack is taking care of LLB Environ. Please do join LLB Environ group.